Evening, everyone. Good evening, everyone. A very warm welcome to our esteemed speakers and participants in the third masterclass on early warning systems for heat stress, which is organized as a part of South Asia Heat Health Information Network series on heat stress. SAHIN is an independent scientific platform for scientists, health experts, policymakers, government, and stakeholders to collaborate and evolve strategies that expedite heat stress management in South Asian cities and beyond. Just to share, this masterclass series has this masterclass series aims to share actionable information that can be used for a better heat wave management in cities, states, and the countries. Today's masterclass on early warning system for heat stress will enable the cities to efficiently prepare, mitigate, and adapt to heat stress induced by climate change. This masterclass will be delivered by Professor Ajit Tyagi, Senior Advisor, IRADE, with Q&A moderation by Dr. A.K. Sahai, Senior Scientist, IITM Pune. The special remarks will be given by Professor Dilip Mavalankar, Director, IIPH, Gandhinagar. The welcome remarks will be given by Mr. Rohit Magotra, Deputy Director, IRADE. Mr. Rohit Magotra is leading the climate change and urban development work at IRADE and is a principal investigator of the project on climate adaptive action plans to manage heat stress in Indian cities, and on heat hotspot delineation. Over to you, Mr. Magotra.
Yeah, thank you, Nimisha. And I once again welcome you all on the third masterclass on early warning systems. We had two masterclasses earlier on the topics related to developing climate adaptive heat action plans, and another on the methodologies to identify urban heat stress thresholds. So this is the third masterclass in that series. And we are very privileged to have today Professor Ajit Tyagi, who will be delivering the masterclass. So Professor Tyagi is a senior advisor, IRADE, and he has been supporting IRADE in its climate change and urban work for last more than 5 years. And under his guidance and support, we have been able to work on several issues related to climate change and health. And he has been key and instrumental in guiding us to work with both cities, states, and at national level for policy inputs for developing climate adaptive heat action plans. Professor Tyagi is a former Director General of IMD, and he is a well-known meteorologist and climate expert. His specific domain areas of expertise include weather forecasting, early warning systems, and climate services. He's also a member of World Tropical Meteorological Research Group of WMO, and he has served as a Koteswaram Chair Professor with the Ministry of Earth Sciences, working in areas of weather, environment, and climate. Professor Tyagi has played a key role in promoting climate services at national, regional, and global level. Under his esteemed guidance, he has carried out modernization of Indian Meteorological Department and brought significant improvements in weather forecasting and warning of high impact weather events in the country. He also serves as the president of Indian Meteorological Society. He was former Indian Meteorological Society president, and he's also former chairman of South Asia Meteorological Association. So thank you, sir, for joining. Further, we have with us very distinguished Professor Dilip Mavalankar, who has played an instrumental role in developing heat action plan for the city of Ahmedabad and guiding many other cities for developing the heat action plan. He has been instrumental in bringing forth the heat action plan as a important measure for further strengthening the adaptive capacities of the municipalities, states, as well as the country for the heat wave management. He is an MBBS and MD in Preventive and Social Medicine from Gujarat University in Ahmedabad, and a Master in Public Health and Doctorate in Public Health from Johns Hopkins Schools of Hygiene and Public Health, USA. He has held several faculty and research positions, and he is actively involved in research focused on improving management of heat stress issues. Thank you, sir, for joining. We also have with us Dr. A.K. Sahai, who is a senior scientist at IITM. His work has led to the development and operationalization of a dynamic ensemble system for predicting heat and cold wave, onset and active break cycles of monsoon in advance. As the head climate research and services, IMD Pune, he has implemented global framework for climate services and established a regional climate center. In recognition of his expertise, Dr. Sahai has been appointed as a member of Scientific Steering Committee of World Weather Research Program 2019 to 2022 of WMO. So thank you, sir, again for joining. So with this brief introduction of the panelist as well as our masterclass presenter, I am requesting Professor Ajit Tyagi to, before that, I like to request Dr. Mavlankar to kindly give the inaugural address for this masterclass. Thank you, sir. Thank you all.
Thank you very much, Rohit. I hope you are all able to hear me well.
Yes, sir. Yes, sir.
As Director of Indian Institute of Public Health, I am delighted to join this masterclass and give you some opening remarks. First of all, thanks for inviting me. Thanks to Irade and Sahin for inviting me, as well as IDRC, who is supporting this effort. Indian Institute of Public Health is the first public health university of India. We run Master of Public Health, Master of Hospital Administration, Postgraduate Diploma in Public Health Management, and other such courses in the field of public health. Public health is a multidisciplinary field where we try to prevent diseases and any other causes of death, including related to climate change. And we have been working with the city of Ahmedabad along with NRDC, which is an American NGO, to help develop South Asia's first heat action plan following a major heat wave in Ahmedabad in 2010. Since 2011, we have been working on the correlation of this heat wave in the city with the registered mortality, all-cause mortality in Ahmedabad, and we found that within 1 week of the heat wave, there were 800 additional deaths in Ahmedabad, and that started the interest of the city and other stakeholders to develop this heat action plan. And since 2012-13, we have been continuously working with the city and later on with the National Disaster Management Authority to develop city-based heat action plans and state-based heat action plans, which are based on thresholds which are determined based on mortality if possible, or morbidity, or from temperature percentiles. And this has now been replicated in many cities in India and several states. The main part is the early warning system of the city or the state, and this is what the master class focuses on. Now, before 2016, the India Meteorology Department was not able to, or not focusing on early warning in the heat at the city level. And hence, we had to depend on Georgia Tech, International Center for Weather Research in Georgia Tech, which provided the city level early predictions of temperatures and the likelihood of reaching those temperatures 7 days in advance. From 2016 onwards, the India Meteorology Department started focusing on heat wave related early warning systems and predicting temperatures in more than 300 cities in India. And since then, the progress has been phenomenal. We have now more than 500 cities where city-based prediction of temperatures for next 5 days are available every evening through the India Meteorology Department. And this then is taken up by the city or the state governments and issue warnings based on what the temperature is likely to reach. Now, the early warning system has two parts. One is the prediction part, which is done by the weather department. And second is the warning system, which the city or state has to develop using its own health departments or publicity departments, municipal information networks, etc. And then the actions to be taken by various wings of the government. So if you alert people, half of your problem could be solved because people have to take most of the actions to prevent exposure to heat. And if heat exposure happens, what to do? Second, the health system becomes ready for receiving emergencies, because whatever you do, some people will be exposed to high temperatures, will develop some direct or indirect heat strokes and will land up in the health system. So we have to also involve the health system in the alert system, so they are prepared, the ambulance services, the emergency departments, the casualty departments of hospitals, so that those who receive, those who get affected by the heat are immediately treated and mortality or severe morbidity is avoided. The third is the alert should also lead to short-term actions which are possible within few days, to long-term actions which people will have to take and governments will have to mandate in terms of building construction code, which can be changed so that exposure to heat within the buildings can be reduced through cool roof and other measures. Now, with the advent of social media, the warning systems have to be in tune and in collaboration with the authorities. People can receive messages very fast and can spread it very fast through social media. So over the last few years, we have been also using social media to alert people. And what we have been able to do through the heat action plan work is to show that mortality and morbidity does go down if you have a good early warning system and appropriate actions are taken. The data from Ahmedabad shows that at peak heat wave times, we have been able to reduce the mortality by 30 to 40% in subsequent year heat waves. If you look at the data from the National Disaster Management Authority, the mortality registered, of course, that is not the right number because there may be under registration, but that also has gone down substantially. The last point I want to make is any early warning system which is developed in the connection with heat may be also useful for other natural disasters, because in Indian subcontinent after heat season is over, we have monsoon, and now the weather is also become very unpredictable in monsoon. So flooding and other natural disasters, cyclones, etc., maybe also the same warning system can be used because the meteorology department does the prediction. So if we have a strong warning system for heat, the same thing can be used for monsoon weather warnings, or even in some parts of South Asia where there are mountainous areas, cold wave warning. The mortality because of cold wave is also substantial, especially in old people and young infants. With that, let me again thank the organizers for giving me this opportunity. Thank you very much.
Thank you very much, sir. I think the significance of the early warning has been something which you have always included and designed as a part of your heat action plans. And I think the best example is what we have in terms of early warning interpretation as alerts, color-coded alert system, like yellow, orange, and red. So these kind of alert systems have been truly been helpful for communities as well as the departments which have to take action. So thank you, sir. And I'm requesting now Professor Tyagi to kindly deliver his masterclass address on early warning systems. Over to you, sir. Thank you so much.
Thank you, Rohit, and a very good evening. Am I audible?
Yes, sir. You are audible, sir.
Okay,
You are audible.
thank you. It's a great pleasure to deliver the third master class in the series of the master classes being organized by Sahin, an initiative by IRADE and IDRC to promote the public awareness about the heat waves in the South Asian region, link it with the global initiatives, and also sharing the knowledge among the various stakeholders in the South Asian region. The earlier two master classes dealt with the threshold and the climate adaptive heat action plan, and this brings in the early warning system which links the two. Professor Mulankar, who had been, I think, pioneer work done in formulating and implementing heat action plans, first in Ahmedabad and then through NDMA in many states and cities, has summed up my talk, I think, and I'll be elaborating some of points he has raised. Rightly brought out that it was a 2016 had been a hallmark in operationalizing an early warning system for the heat waves. See, if you look at IMD had been issuing heat wave warnings for at least 5 decades, but there were no takers. And such general warnings or general forecasts that carries no meaning unless they get integrated into the system, as has been done in the case of heat action plan, and also the cyclone warning and many other systems. So also I am happy that today we have Dr. Sahai, who had done pioneer work in early warning systems, particularly in the extended range. Also Rohit in IRADE, who has been now developing climate adaptive heat action plan, and up to ward level how the heat action plan can be implemented. I'd like to acknowledge the work done by the India Met Department in improving the early warning systems, both in space and time. We have now more than 500 cities, and our forecast now extends from short range to extended range to the seasonal range. In my presentations, I have made extensive use of the slides provided by Dr. Bhan, who has been coordinating the early warning systems from the IMD side. And I'm thankful to him for providing those things, because it is the official presentations from the IMD side which forms a part of my presentation. So thank you, Dr. Bhan. I have tried to give a big picture, give a background information about the heat wave as such, and then focus on the early warning system. And bear with me for the earlier slides, which to many maybe they are aware, but maybe for someone or some of you may not be there. So I have given a global perspective, then characteristic of features of the heat waves we should understand before we appreciate the early warning system, which has now become, as brought out from forecasting to warning to the action oriented by the administration, and then how it is getting integrated in the heat stress management. Now, globally, if you look at it, we are fortunate that in the universe, which is infinite, Earth is the only planet where the living organism biodiversity exists, and this is because of very favorable climatic conditions. And climate system consists not only of the atmosphere, but also biosphere, hydrosphere, geosphere, and cryosphere. And they were in the balance till recently, and things were okay. But in recent decades, because of anthropogenic activities, there had been leading to global warming and its impacts, which the scientists had been saying for last 3 to 4 decades that we are in the phase of global warming, but skeptics and many politicians and the lobbies were not giving due attention to this fact. We have to now start feeling the pinch of it, the impact of it, and started paying the price of it. And as rightly brought out by the IPCC chairman on 9th August, while releasing the Group 1 report, that it is a now code red for the humidity, and whatever damage we have done to the climate systems is becoming irreversible in many cases and putting billions of people on the risk. So this is now in dispute, irrefutable fact based on the observations, hard observations of last 200 years, where we have got observation data that climate change is taking place and the rate of climate change is accelerating. It's not only the scientists, but even the business leaders and economic community is now identifying the weather-related events as a major top risk. 5 out of the 10 top risks by the World Economic Forum last year was weather-related, and of these, the extreme heat was the highest one, the 88.8%. So it's now even the business community is now appreciating that climate risk and heat-related risks are going to play a vital role. Now, heat waves for the tropical countries, we were used to it. We had acclimatized to it. Our living systems were able to manage it, but recent changes because of urbanization, migration, and changes in the living habits have created the heat wave as a hazard, and now it is assuming a disaster proportion. And especially it spread into the higher latitudes, Europe, which has resulted in large number of deaths, as in the Western Europe. In 2003, 70,000 people were killed, and Russia in 2010, more than 55,000 people were killed. So it is real. It is happening in the different parts of the world, both northern and southern hemisphere. But to understand these features, so why I'm trying to bring it out here is that the heat waves are global. They are not uniformly global, but they are global. They have got regional features in them. Then in the urban areas, this is becoming much more prominent. And within the urban area, there are urban heat islands where they become much more dangerous and serious. In the time scales, we have got climate time scales, which is over the decades and centuries that it's making the heat waves are becoming significant because of global warming. We have got seasonal variations where for in some seasons we find significant heat wave, and they may extend for many months in the season. So this is becoming another important feature. It is not just that in some cases they can extend up to the season, and then we have got for days together, 2, 3, 5 days, which happens, and also the diurnal variation in the heat waves take place. And it's not only the health part, which we are primarily focusing now because of the lives are very precious, but all allied activities where the heat waves are making impact. And it is now for us that we start taking note of it and start making heat action plan for all of these sectors holistically, because all of these are going to create a big problem in the years to come because of the increasing temperatures and the climate change. Now, if you look at the global temperature, last year, 2020, here you see that most of the area is painted on the pinkish to the red, which is above normal temperatures, and the dark red is significantly above temperatures. So it's not that it is confined to even the oceans, Pacific and the Indian Oceans are becoming warmer. So the marine life is also under danger. And the temperatures last 200 years where we have got observational data, instrumented observational data, we find that in last 50 years, there has been significant increase in the temperatures. And in last 100 years, the temperatures have risen by 102 degrees centigrade. And this is surprising that last year being a La Nina year and there were lockdown, not much of economic activities, aviation activity. Despite of that, last year was one of the warmest year along with the 2016. And if you look at the last decade, this has been the warmest decade, and last 6 years have been the warmest 6 years. So we are now undergoing phase which is positively and very, very marked increase in the heat in the atmospheric system and the global system. And this is being contributed, as all of know, because of greenhouse gases, which is increasing. It has crossed more than 400 ppm of carbon dioxide. Regional features, last year the Siberia for 6 months was having above normal temperatures, very unusual. And Arctic Circle had 30 degrees centigrade and more than this temperature. And in Siberia, the one station recorded more than 38 degrees centigrade, which normally has temperatures less than 10 to 15 degrees centigrade. Apart from the Siberia, there were pockets of very high temperatures and hotspots in US, Australia, Europe, and the drought also was experienced in South America and parts of South Africa. So it is becoming a global feature. And even this year, the heat waves started in May, June in Eastern Europe and Russia. The Arctic Circle recorded 30 degrees centigrade. Then in July, Northwest USA had a heat wave. British Columbia recorded 49.7 degrees centigrade. So these are the range of temperatures which are being recorded. And there was a mass extinction of the sea creatures in the parts of Canadian coast. In August, Southern Europe is having now the heat wave impact with the wildfires in Spain, Portugal, Italy. So this is happening, and wildfires in Siberia, USA, Europe, Australia, South America, and India also. Uttarakhand, Himachal Pradesh, Orissa, Manipur, Nagaland have been experiencing the wildfires. So this is becoming a cause of concern for everyone. And if you look at our neighboring countries in South Asia, all the countries are showing rise in temperature. And most of the areas are showing a rise in temperature in the country, but for some pockets in the southwestern Rajasthan and adjoining, and also in Bihar. But rest of the countries are showing rise of temperature. And if you look at the temperature, the progression of temperatures is seasonal. It starts in the month of March in southern parts and moves northwards, and in the northwest India and Pakistan, it continues till the middle of July. So from March till July, we have a spell of high temperatures, which is get impacted because of heat waves. And the states which used to be primarily confined to the northern states, now up to Kerala, we are having the heat waves. The last year, 23 states recorded heat wave out of 30 heat waves. So this is the increasing incidence of heat waves over the period of time. And also the spread of heat waves, as I said, is increasing from north to south and the eastern parts of the country. The urbanization is another major factor, because now more than 50% population is living in the cities. And in India also, we are now moving towards halfway mark by the middle of the century. So, now urban heat islands becomes a major cause of concern. Temperatures could be generally higher 1 to 3 degrees centigrade than the surroundings, and in some cases can be as high as 9 to 12 degrees centigrade. So this is typically variation of the temperatures in the center of the city to the neighborhood. And as mentioned, the variations can be 3 degrees centigrade, and there is also a diurnal variations which takes place, which has become significant in the night time. And this causes demand for higher energy for air conditioning, and the waste energy again contributes to the urban heat island. So this is a cyclic process which contributes to each other and causes the urban heat islands to continue for a long period. This is the Delhi urban heat island. Now here we can see that there are forested areas, some areas which are green areas are having lower temperatures as compared to the western parts, which are densely populated now, and the difference between these two parts were 5 to 6 degrees centigrade on 30th May, where as high as 48 degrees centigrade temperatures were recorded. This is the microclimate of Delhi. So you have got pockets which are got high temperatures and which requires special attention while carrying out issuing the early warning systems. Okay, and this is the Bangalore city, which used to be a green city, but here also we could see the red hotspots which are emerging because of urbanization. So in the country, we are having now growth of cities taking place. So there are many cities that are crossing 10 lakh mark, and so this is going to be that, though we are now giving forecast of 500 cities to cater for most of the cities which are more than 1 lakh for issuing the heat wave warnings. Now, these are the mega cities of South Asia, which needs special attention. Apart from India, we have got Dhaka, Karachi, Lahore, which are also important cities as far as the urbanization is concerned and needs to be addressed their heat wave issues. Now, the early warning system, as Professor Mavlankar brought out, that the early warning system now has become a value chain issue. You do forecast, and India Met Department and Met Services have been giving forecasts for years together. The disaster management were essentially doing a response work, rehabilitation. But now the focus is on preparedness and disaster risk reduction. So this requires advanced knowledge of the hazards, exposure, vulnerability. And in this framework, we need to integrate the forecasting systems with the early warning systems and the stakeholders which are going to implement these warnings on the ground, including the public awareness, capacity building. And over a period of time, because of technological advancements, there has been improvement in the early warning system, which is contributing to many of these reduction in the mortality, particularly in the case of cyclones and now in the case of heat waves. So now the recognized early warning system is an integrated system of hazard monitoring, forecasting, and prediction. So this is what the meteorological services provide. But along with this, we have to have an understanding of the disaster risk assessment, communication, and preparedness activity system that enables, see, the action-oriented early warning system is there. Individuals, communities, governments, and businesses and others to reduce disaster risks in the advance of hazardous event. So it is preparedness and prevention which is demanded from the early warning system. So if we look at the early warning system, the improvement, as far as from the India Met Department and the weather services are concerned, we have moved from a synoptic, which used to be just 200, 250 observations in the entire country, to a multi-sensor observations now, which is satellite radars, aircraft, automatic weather stations, ARGs, environmental monitoring. So we have now a fairly good observing system, which is able to give us monitoring of any hazardous event well in time. And we are able to receive this time as compared to which we used to receive by telegrams earlier. And we are able to analyze the large amount of this data by computers, not manually, which was being done earlier. And the forecasting, we moved from subjective synoptic forecasting, by which we were able to forecast just for a day or two, to a numerical weather prediction system, which is now well structured and advanced system, which we are able to forecast right from the short range and now pass to the climate projections. And warnings, which used to be very general. We used to give warnings which were general, but now we are trying to incorporate the impact-based warnings so that for each parameter and each location, we are able to should have a threshold where we can issue the impact-based warning. And dissemination, as you know now with the social media, it is becoming real-time multimedia based. So there has been a significant improvement in all aspects of early warning system. And as I mentioned, We have now moved from which used to be general forecast. I issue a forecast and say that yes, some rain will take place in this part of the country. Then depending on the intensity of the forecast, we started issuing the warnings, which were also used to be general warnings, but now we have started specific warning for each element, the temperature, the rainfall, the winds. So, and then the element-based warning. And then we are now migrating to the impact-based warning and risk-based warning. So the early warning systems are now meeting the requirement of integrated warning systems, which are working. And this is what the early warning systems value chain is there, which starts with the observations where we have got improved sensors to the weather forecast. Atmospheric modeling plays a very important role. Hazard forecast, where we take into consider the environmental conditions. Impact forecast, again, the modeling of the socio-economic vulnerabilities. Warnings tailored to the, with the help of the communication experts. And finally, decision making, which includes the behavior, psychology, public awareness, and many other factors. All these are the value chain which the early warning systems are now getting established, and we are working towards this in the country also. Now, the value chain, as I brought out, one is part is the atmosphere, the meteorological part, but to convert this into value chain impact-based, we need thresholds. And in case of heat waves, we used to have just the meteorological thresholds earlier based on the climatological data. But now, as Professor Maudankar brought out, the health-related data, all-cause mortality has been linked in some cities where data were available. And we are able to have a new thresholds, and based on that, the temperature forecasts are given, and then the different alerts in different ranges, yellow, orange, red are given, and accordingly, the follow-up action is taken. So we need to have such thresholds, not only just for the human health, but much more. And even in the human health, the data should incorporate the socio-economic modeling, the habitats, and many other factors to improve the quality of these impact-based warnings. Of course, the communication is very important, and communications to the last person, targeted person, in the language which he understands, and the actions to be taken by him or by the community are conveyed properly. It does call for behavioral changes in many cases, and multi-stakeholder participation is very critical because each in this value chain has to play a very important role as a team. And wherever such team, like in case of heat action plants, have played their role, it has been a great success. So as of now, the impact-based warning for the heat waves, it used to be by IMD, which used to give heat waves based on the climatological criteria of departures from the normal for the heat waves and the severe heat waves, both for the plains, coastal areas, and the hilly areas. So this was one way of issuing warning, but these were for general large area warnings. And we found that yes, within those large areas, the cities have different thresholds. So based on the health data, this has come up, as in the case of Ahmedabad, Nagpur, and Surat and Bhubaneswar, that you have to have city-specific thresholds available. And now this health data is a challenge which Dr. Maudankar has been advocating for a long time. And NDMA also has realized that this data is difficult to come. So as an alternate, they have come up with the IMD, in which NDMA, IIPH, and the IMD, Dr. Bhan, Dr. Maudankar, and the NDMA have been able to formulate 100 city thresholds based on the percentile of the data of last 30 years. So this is one way of addressing to this part of it, apart from the observed health impacts, which is the mortality and also the combined data. This is what the study by NDMA with the expert teams constituted has been able to brought out the thresholds, which is a good beginning. So we have got 75%, 85%, 95% for hot days, heat waves, and the severe heat waves. but what we require is the high resolution data. Now, as of now, in the city, we have got just one observation. Big cities like Delhi, just two observations are there. Now, we have been able to set up a urban network, so we have got more number of that, but most of the cities have got just one or two observations. But we require now high resolution meteorological data, not only of the temperature, but humidity, wind, and also we also need to have a health data, not only of the overall mortality, but also based on gender, age, and many other factors of the comorbidity. Socio-economic data is very important to know the vulnerabilities, the habitat, the living conditions there. The heat index, we don't have heat index for South Asia. This needs to be developed and validated for South Asian countries. And also, apart from the human health has brought out, there are productivity issues. There are so many important sectors are there, the energy, water, food, agriculture, part of it is there. So for each thresholds are to be determined for the meteorological services to provide sector-specific heat wave warnings, early warning system. So this is a lot of work needs to be done for thresholds. As far as meteorology is concerned, the meteorological services are concerned, they are now at a stage where they can provide, at least the data related to these meteorological data at high resolution, which could be converted into the warnings based on the thresholds. Okay. Now, so apart from the impact-based, has brought out the communication, behavior change, and multi-stakeholder participation is very essential, and I am happy that in the case of heat action plan, the early warning system triggers the part of it, but the downstream, it is so well integrated with interagency emergency response plan in place. The public awareness and community outreach is done well in advance. Capacity building is ongoing exercise, and in practice during the summer season, reducing heat exposure and promoting adaptive measures are being done so effectively, which has resulted in reduction of heat wave deaths in Ahmedabad and many other cities. Now, early warning systems, the time scale now are becoming significant, right from the climate projections to the nowcast. So entire range of these forecasts are being provided, which are now being converted into the warnings. So the numerical weather predictions are the key to drive these things, which the models have now improved over a period of time, which now incorporates the real lifetime systems in the atmosphere, biosphere, geosphere, and cryosphere, all gets factored. Now you see here, if you see the progress of modeling from 1975, which used to be just simple atmospheric model, to atmospheric and land surfaces, oceanic, now chemical, biological, carbon, all these things are getting integrated and coupled model with the oceans. We have got climate models which are perfect, near perfect, I must say, part of it with a high amount of certainties in their predictions on the large scale. I won't say at the high resolution, but as a general trend, there is a consensus that climate models during the AR5 and AR6 are fairly consistent in their predictions, and they are also able to bring out the impacts on these projections on various sectors. So this has been possible because of high power computing, which started in 1988 in the country with the Cray XMP, and now we have got 8 petaflop of supercomputer with the MOES at institutions at IIT Pune, NCMRWF, and the INCOIS. So this is the 4th fastest computer for the available with any weather service in the world. So it is going to be upgraded to 80 petaflops in coming years. So we have a world-class computing powers and modeling facilities now available to provide early warnings for various factors, parameters, and IITM Earth System model, which has been developed now, is proud of AR6 part of this. And this is very significant development for the country to be proud of it. And you see that amount of data which is going into the model because of the satellite radar has increased exponentially, and we have got good about 200, more than 200 GB data going in every assimilation cycles in the models. And these projections, which were AR5, are well known to you, that we have a fairly good consensus as far as temperature rise is concerned, that it could be, if in the case of stabilized things, 1.5, but it can go as high as up to 4.5 and above if we don't take mitigation measures well in advance. So it starts with 1 degree centigrade in the mid-century to 3.7 part in the end of the century. So based on our high resolution projections done by the IITM, assessment has been done for Indian region, which also shows that temperatures will rise to 2.2 degrees centigrade or so in the coming years if we don't address the mitigations, which will bring down the temperatures to less than to close to 1.5. Otherwise, we can go up as high as 5 degrees centigrade. And these are the areas where the temperatures will be rising. Upper panel shows RCP 4.5 and below one 8.5. And in under 8.5, we can go entire country rising temperatures by 3 to 4 degrees centigrade. Whereas in the case of 2.5 and 4.5, temperatures will be 1 to 1.5 degrees centigrade, primarily confined to the north and northwest India. And the projection of heat wave events and days are going to increase as expected because of the rising temperatures, and both the duration and intensity of heat waves also going to increase. Now, these are the slides from the Dr. Bhan, provided by the Dr. Bhan, and I summarizes, you see the entire heat wave overview in this slide, which says that typically heat waves are 3 to 5 days and 5 to 6 days, and severe heat waves 2 to 3 days. They extend southeastwards from northwest India, and the criteria as brought out here is for the plains, for the coastal areas, and for the hills are given, and the departures for the severe heat wave and the normal heat wave is also here, 4.5 to 6.4 degrees centigrade for the normal heat wave, and for severe heat wave greater than 6.4 degrees centigrade. Now, the forecast systems, you see, what I appreciate about IMD is that they have gone very systematically to provide a telescopic forecast warnings for the heat waves based on the global models, the extended range prediction systems, and short range and high resolution models. So there are a series of forecasting systems which are being used now to provide, starting from the seasonal outlook, which starts as early as in the month of February, to provide a monthly forecast in the seasonal forecast. So you have an idea whether how the temperatures are going to be in the coming season. So at a macro scale, decision makers can make adjustments and preparations. Then we have got extended range predictions, which Dr. Sai pioneered in IITM and now has been operationalized by IMD, which provides forecast for next 4 weeks, both for maximum temperature and minimum temperatures and departures. So given areas are going to be have potential to develop into heat waves, and then the medium range forecast, as Dr. Mahavankar has brought out, gives us 500 cities forecast up to 7 days now. So it's not only 5 days now, we are going up to 7 days of maximum minimum temperature. And then the short wave of 2 to 3 days forecast, where we go in detail on early temperatures, details are there, and how the evolution of maximum minimum temperature take place. So you have got now information, right, starting from the seasonal outlook to the short range predictions, and these warnings are given well in advance to all the stakeholders. So these are the typical warnings, which starts and we'll give a temperatures how each met subdivision in the states will have temperatures from the normal, plus, minus, above normal, below normal. And then we also give these are the extended range predictions, which covers the areas like in this case, the southern parts of the country are having going to have higher temperatures out of it. And this is the anomaly which is there. Progression of this is also shown here. So you can monitor how the maximum temperatures are going to evolve over a period of time. This is how the 5 days heat wave warnings in the color code is given. The red is the severe, orange is a normal heat wave, the hot days, and the no warnings for the heat wave. So such forecasts and the warnings are available well in advance for the decision makers to take necessary action. Now we have also started high resolution for the city specific. It has been being implemented in the city. 3 kilometer resolution model is there, and they are working now for 300-meter city level, street level model also, which provides winds, temperature, humidity, part of it. So this is the temperatures in the afternoon, the high temperatures which is seen in the center of the city, and the surrounding areas are relatively cooler in the. So this is the recent 2nd September forecast, and this is 4th September. So 3-day forecast is available from here, and we have now capabilities to provide for entire South Asian and adjoining areas the forecast based on our NWP and several forecasts. So for South Asian countries, the IITM, IMEDIAN, and CMR developed systems are now in a position to provide these guidance and the forecast. And if the ground data of the health is available and thresholds are available, these can be converted into the warnings. And of course, because of these interventions pioneered by the Ahmedabad and now adapted by the NDMA, by the leadership of NDMA through by various states and cities, there has been a drastic and significant decrease in the mortality in last 4 years after 2015 onwards. And this is a real acknowledgement of that. Yes, if a good early warning system and heat action plan gets integrated with the heat action plan, then you are able to bring down the mortality part of it. Now, but as brought out earlier, this is not sufficient. We are having, see, at a tipping point that if we don't act now, there is going to be wide divergence by the middle of century and towards the end of the century, where it will be very difficult, like what is happening in Europe can start happening in many parts of the world, where people in thousands, like in COVID, start succumbing to the heat waves. So this is a warning sign for all of us. And heat and humidity, because of the global warming, there will be more moisture in the atmosphere, and this heat and humidity combinations is going to become deadly, because we know that wet bulb temperature for more than 30 starts becoming critical, and beyond 35 degree wet bulb temperature, it becomes fatal. So, and with the increase in humidity and the continuing rise in the temperatures, this is going to be very, very significant. And of course, this is going to bring down the reduction in the productivity and many sectors will be affected because of this chronic heat. Now, another thing which is there is not that heat waves are going to be for a short period. They may persist for a longer period and will going to create much more implications on the human health, productivity, and infrastructure part of it. And these are the many of the cities in the South Asia are in the threshold of 25 to 30 degrees centigrade wet bulb temperature already, and with increased humidity and the temperatures in coming years may cross 30 degrees, touching to 35 degrees, which is may become a fatal things. Now, in the country, we have a temperatures which more than 45 degrees centigrade. Many of these cities have already recorded. And now with the compound factor of climate change, synoptic systems, which anticyclones, which gives rise to heat wave, we may reach scale and the degree which may become, see, unthinkable as of now. Suppose we are at a raise of 42 degrees centigrade for Delhi, with the temperatures may rise because of the climate change. The mean temperature may rise to 45, and there is a synoptic anticyclonic system which happens in many cases, which may become more prominent during the climate change. Like temperatures may rise to 5 to 7 degrees centigrade during that period. So temperatures goes into 50s. And if there are urban heat island spots, which are again going to be even more higher than 3 to 5 degrees centigrade, we can end up in a real problem. And this is going to happen if temperature is 1.5 degrees centigrade. I'd expect like you to focus on the Indian region, which is showing dark color, which keeps on increasing with the temperature rise to 3 degrees centigrade. Most of the country get covered because of the adverse impact because of heat wave part of it. So essentially what mitigation part is required. So, and one of the initiative which is being taken is white versus black roof, which can be implemented in a faster way in the cities. And studies have shown that the temperature fall reduction of 5 to 7 degrees centigrade can take place because of this. So we have to start adoption, which is needs to start at ward level early warning system, which is very much required now from city level with the adequate communication response mechanism. Awareness about risk factors are to be communicated through the public awareness part of it, and functioning of medical, energy and water systems, we need to assume it. So with this, if we have to act now, otherwise the mitigations will don't take place, we are in trouble. So we have to act to save the planet. Early warning systems, as I mentioned, you are now capable of providing information in the time scales, right from climate projections to the nowcast. This needs to be fine-tuned with the thresholds which are to be worked out for each sector and for each area, because they are location specific, sector specific, and of course various vulnerabilities, socioeconomic, also needs to be factored in. Then only the perfect, I think, disaster risk reduction and mitigation based on the early warning system can work. Thank you so much. And I'm sorry if I've taken some more time, but I thought that it should be holistically covered to provide you a big picture about the early warning system. Thank you. Jay.
Thank you, sir. Thank you for such an extensive presentation and also covering the topics, not just from the early warning point of view, but also from the various developments which have happened in the early warning systems. And I think this actually raises a lot of questions, and the question and answers will be further moderated by Dr. Sahai, who's our guest for the day. And I would, before responding to the questions, I would request Dr. Sahai to kindly share his comments on the presentation and any other observations or suggestions he may have on the early warning system. Yeah. So over to you, sir.
Thank you, Mr. Rohit. And it was very nice and exhaustive presentation by Professor Tyagi sir. And he has covered all the aspects of heat wave, from what will be there in the end of century, in the near future, that is by 2030, 1.5, or how it will go to 4 or something like that. And then the various stages of forecast, from seasonal to extended range to short range to nowcast of the cities. So and then he has also not only emphasized on the early warning system, but how, as Professor Malvankar has also raised in the beginning, that how these forecasts can be clubbed and with the health data and other things. So as Professor Malvankar has told that not only for heat wave, for cold wave, for anything, it is forecast, meteorological forecasts are there, and they are now quite, means you can say that accurate in that sense, but still, and that progress is required, and that is every passing season, some new things are being added by meteorological department. Particularly, as Professor Tyagi has told, that the most significant contribution is the high performance computing system. So that is now, again, we are going to upgrade it more 10 times what we are having at present. So these are the things, and with that, with more better models which are resolving better physical processes and also high resolution, I'm sure that we will be going to, we will be doing good early warning system. But then, as Professor Tyagi has told, it is very much required to add with this other data sets like health data, and not only health data, socio-economic data, because same heat wave affecting in the nearby slums and through those people who are of means aged people, children, and those who are already sick people, and those who are laborers, and those who are working in air conditions. So all those things are different. So therefore, we have to come up with the socioeconomic data and health data, and together with our early forecasting system for all the what is the risk associated, and how we can give the, and what will be the impact, and how we will give the forecast. So this is what one very important thing is nowadays. If you see the years which are more hotter than normal, and also longer heat waves or more heat wave days are there in some parts of Maharashtra, in Vidarbha and other regions. Those years are also, means the previous years it was drought-like condition. So when drought-like condition is evolving with very hot conditions in the heat wave conditions, then the planning, mitigation planning and other things will be totally different. Because if this year is very good, monsoon is very good, a lot of water is there, so next year even the impact of heat wave, even it will be severe heat wave, will not be that much. If this year is a drought year and next year is going to be a very severe heat waves and other conditions. So this type of things also has to be included in our policies. Now, I don't see there are any questions in the chat box. So, but if anyone wants
there
to
are,
ask,
yeah.
so there is only one question from Rohit that
Yeah, I have asked.
are there any city level risk maps based on IITM codex? So I don't know, IITM has not prepared this risk map. So I can't say that there is available.
Sir, second question I also want to bring in, if you allow me. So,
Yes.
sir, how do we kind of, take this, since as a Sahin, we are looking into, Sahin is a network of South Asian countries, and where we are engaging with scientists, government departments and citizens on creating more awareness and also dissemination of research related to the heat waves. So early warning system is of critical importance for the South Asian countries as well. So while we are looking at a collaborations with Bangladesh and Sri Lanka, so what kind of, sir, kind of a information which could be kind of strengthen, forecasting in these countries, or what has been your overall kind of understanding of the systems which exist in this country, and whether there's a possibility of a kind of a peer-to-peer learning, uh, peer-to-peer learning from Indian lessons to strengthen these cities? Are there any mechanisms which exist where we could kind of engage with these countries as well?
Yeah, there is already in India Meteorological Department, Pune, they are issuing regional forecasts. And Dr. Tyagi has also shown in the last slide some how we are issuing the whole globe, and we have the capability of issuing forecast on regional level. But if you see the heat waves in India, as Professor Tyagi has also shown the importance of humidity, but that is so far that is not much more important, because the areas which are more prone to heat waves, now it is now expanding to coastal regions and this, but earlier the area which are more prone to heat waves and the season, March, April, May, and early June also you can say. So these, when monsoon onset is not there, so there is humidity is not that much problem in the most parts of India where heat waves are generally occurring. But when you go to Sri Lanka and to Bangladesh, then humidity definitely is will be one aspect which we have to consider, and therefore the heat indices based on maximum temperature and humidity has to be developed separately for Bangladesh and Sri Lanka. But we have the capability, and data Sri Lanka is having very good data for health and other category, that how which this date is due to which region and all those things they are, but I don't know how much good data is there in Bangladesh, because even in India also we are struggling for standard data. So this is one aspect if you want to relate it with impact and other things. But early warning system we are having, and as you told in the beginning that how we can expand it. So Professor Tyagi has already shown that we have started urban networks of observations, but that is still in very limited one or two cities. But that is very much required. Unless you measure the temperature at different locations in the city, how will you prepare information? Because we have to know, and even if the forecasts from the models are not on the, you can say, colony level or not on the very high resolution, but these, if informations are observed, informations are available, that can be superimposed on this, and using machine learning and other things, we can generate forecast even for very small regional scale.
Ward levels, we
Yeah,
have been trying to look at, what kind of spatial variability exists within the city. So though we are trying to use right now the satellite data and looking at the LSTs, but I think these campaigns are very important to look at the spatial differentiation of temperatures within the city.
But you have to now, since AI ML tools are available and good scientists are also available in that field, only model forecast as it is what we are getting from the model cannot serve this purpose of high resolution ward level and this very localized information. For that, we have to combine with this forecast with machine learning and this, and then we have to come to it.
Sir, there was one more question, which if there are no more other questions, then I can ask this. If there are questions, then we can just check if there are other questions, or I have one more question.
No, there is Mohit Kumar is asking, the need of the hour today is to have prior information on urban heat hot spots. Can the IITM high resolution model be used for dynamical dimensional scaling of the information ward levels? Yes, you can use it, but ward, yeah, but still it is very difficult. On the ward level, you can do the down scaling. So maybe from 100 kilometer from by 100 kilometer to 1 kilometer by 1 kilometer also, that will be not enough for ward level. And then for few days, definitely you can do 2 to 3 days, but then this also requires very big computing system.
Sir, can I add here something?
Yeah.
This is Mohit Kumar. I just asked this question.
Yes.
So just now you said that if there are multiple observations available across the wards in a city, we can use them to correlate with the broader resolution climate models.
Yeah.
For example, if I can get your IITM broader resolution climate model, say for the city of Rajkot, we have some around 24 AWS stations across the wards in Rajkot. So we can develop a model using the data available and see how it gives us about this future hotspots.
Yeah, that is fine. So our forecasts are available whenever you ask any forecast. It may be short range forecast to extended range forecast. Everything is available. You ask, we will provide you data. We are providing this data to various stakeholders, those who are asking for this. Either it is for flood management or drought management or heat wave management and all those things. We are providing our data. So
earlier, there was some around 35 kilometer resolution data being offered freely on this IITM website.
Okay.
And there was another downscale 27 kilometer data, which was not freely accessible. It has been written on the website that it will be made available. So what is the current status of this 27 kilometer resolution data?
This 27 kilometer resolution data, you are saying for climate change applications or for predictions?
Yes, for future predictions.
No, future predictions means next 3 days predictions. That is what
long range. Say
long range is climate scale. No?
Yes.
Yeah, that is Codex data is available.
Yes.
I don't know which data you are saying it is not there. You can write to Dr. Krishnan. He will give the information.
Okay.
Yeah.
Thank you.
Sir, one question I have for Tyagi sir is the increasing talk about the wet bulb temperatures. That's a combination of the high temperatures along with the humidity. So sir, so what kind of early warnings are currently being developed or in being practiced for providing these kind of alerts? It's the coastal areas definitely would be suffering a lot due to the increasing wet bulb temperatures. So what's that? Are there any forecasting systems in practice or which will be available in kind of near future through which populations can be made alert about the same?
It's a good question. As of now, we don't forecast the wet bulb warnings or wet bulb temperature as such. But from our available forecast data, these can easily be generated. There is no big issue as far as because the temperature and humidity data is there. Only thing these needs to be validated and checked on the ground with some observations and then put in practice in the operational mode. So this could be, yes, in coming years, this will become a necessity. So I think it's a good suggestion for IMD to consider that whether wet bulb forecasting also should become part of heat wave action plans.
Yes. Sir, Sai sir, any comment you have on this or any development?
This can be done as Professor Tyagi has told. Temperature is there, humidity is there. Just we have to convert it into wet bulb temperature, and that forecast can be given. That is not a.
Sir, shouldn't we do some campaigns based on the same? Based on the available forecasted data, and on ground we can kind of I'd select a couple of wards within the city and do campaigns continuously over a period of time to kind of see the validity and also vetting of the same. So
But
there's
again,
something, sir, which should
if
be
you are saying that ward level forecasts are not available, so
not
that is the main thing. Even city level also just nowcasts and some 1 day or 2 day forecasts are available, because our forecasts are generally on grid scale. So we and that depends on how big is the grid. So just now for 2-3 days forecast, we are using 12 kilometer by 12 kilometer grid. And also we are down scaling using WRF for 3 days only at 3 kilometer by 3 kilometer. So maximum that 3 kilometer by 3 kilometer data can be made available.
my point was that if we can, make some such vetting campaigns, through which we are able to see, what is being forecasted, it's close to kind of what is actually happening in the field. And that could be a basis for provision of early warning in some coastal cities. We could try with, might be with the Bhubaneswar or might be with Chennai for that matter. So I'm saying that might be that is something which can be done in future, and which could be very useful given that there is already there is a lot of speculation about actually the WTB causing more impacts and deaths due to heat.
Yeah, so one thing is, as you told, campaign based observations first we have to do. And if we are having some continuous observations of at least 3-4 years, then whatever available forecasts are there, they can be transformed into this using any statistical tools or using AI ML or something like that. So a lot of work has to be done with the output of the model to bring on the ward level and this means meeting the real time situations.
Right, sir. Right, sir. Right, sir. Sir, you would have final words, sir. Thank you, sir. Yes,
like
and you want to say? You want to say yes, sir?
No.
I thought you wanted to say something.
Thank you. No doubt with the opening remarks of Professor Maudankar and Dr. Sai being here, concluding parts, both of them have been very active player as far as heat action plan science and implementation. And so I'm happy that they were here and they were able to give a way forward also. And I strongly believe that we have to move beyond existing thresholds to a wider threshold studies. Part of it is brought out here, the socioeconomic aspects, and also for other sectors like energy sector, water sector, seasonal forecast we are giving, how it is being used by these stakeholders is going to be very critical. So we really, when crisis comes, then only we react, but now is the time for us to know, and enough warning signs are there for next 10-15 years. So we start planning now, then only we can start developing these thresholds and start acting. As far as wet bulb temperature forecast is concerned, don't go ward level, you go city level at least to start with. The data is available, and let's see whether that gives some idea, because many of these needs to be validated. The heat index and all that, which is used in European countries, we have not found this useful for the South Asian countries. So we have to test this with the various campaigns to see this data. So we can start with some of these coastal cities, wet bulb temperature forecast, and see on the ground whether it is, again, with the health related, how does it response, and that needs to be worked out. But yes, it is very much will be required with increased humidity and temperatures in coming years. So we have to start working now rather than after 5 years or 10 years. Thank you.
Thank you, sir. Thank you. Sir, I think I would really like to thank you for your time and the kind of extensive presentation you made on the topic. So I'm very sure that the practitioners as well as the researchers and Also the citizens, they would benefit from the topic, and we look forward to if there are any questions related to the today's masterclass, so kindly write to us. We'll provide the email ID on which you can send across your queries, and we'll be very happy to engage further with the participants. And we thank you participants for their participation. I would like to thank Dr. Sahai for his time and valuable inputs and moderating this session. So, sir, we look forward to your continuous guidance and engagement.
Yeah, just I wanted to say
Yes, sir.
that whether these forecasts are being used in energy sector or not, because we are talking mostly in the health sector, death and mortality, morbidity and all those things. But you see, it is very important if IMD is giving that this season, suppose in February, IMD is giving forecast that this season will be hotter than normal. So obviously there are pockets which will be more hotter than what they are experiencing. Then extended and forecast in 3 weeks at least for heat waves and maximum temperature and minimum temperature also are very good. So whether these are being utilized in energy sector to orient their generation and distribution in these areas in the next 10 days, there will be a lot of demand or something like that. And then comes to 3 day, 5 day. So that actually, I don't know, means how it is being utilized in energy.
I think, sir, this is being done with the POSOCO. I am familiar. There was an agreement happening between the IMD and the POSOCO, where they were using this forecast for the planning distribution by the energy demand and the distribution. And also there are a lot of applications which are also happening from the generation point of view, depending on the rainfall and its periodicity. So there are these applications are now actually happening in several countries. And I heard a lot of developments in India also, where this forecasting data is being used by energy companies.
Yeah, POSCO and IMD have got a MOU which they provide this part. How much it is being used, what is the feedback? I am not sure about it, but there is a, and also not only this temperature, even during the winter, you see, because of fog and those conditions, that transmission line used to trip. So as when the forecast is there, they do a spraying on these high tension wires so that tripping doesn't take place. So they do consider. And they were using some of this data without knowing its application is like this. So many of the users are using such data depending on their requirements. This needs to be formalized and improved. Thank you.
Thank you, sir. Thank you again, sir, for your participation. And I would like to thank again all the participants who joined today's masterclass. And at last, I would like to thank all my colleagues at IRADE who worked hard to get this masterclass happening. So thank you to all of you. And with these words, I would like to end this masterclass. Thank you.